Okay, and so here we have one more difference amplifier circuit, right? And for this circuit, we would like to find we'd like to find the difference gain and also the ratios of the resistors, okay, where we actually have a difference amplifier. We'll see that in a minute. We'd also like to find the common mode gain, so we can write an expression for the common mode rejection ratio, right? So let's find the difference gain expression first, right, which will allow us to see what the ratios of the resistors need to be for it to be a difference amplifier by using superposition. So to use superposition, we're going to first go ahead and ground V1 and then put our test source, V2, onto the second op-amp. And when we do that, the first op-amp on the left you can think of it either as an inverting or a non-inverting configuration with the input set to ground potential. And either way, the output will then also be at ground potential. So this right here will be 0 volts here, right? And if you didn't recognize that, take advantage of the virtual short that exists here and recognize that the potential at the negative pin is 0 volts. And that implies that the current I1 will also be 0, and I2 will be 0, and when I2 is 0, the output must also be at 0. And then the right-hand circuit, hopefully you can recognize that it is the non-inverting configuration of the op-amp, because we have the terminal up here at ground potential, and we're putting our signal into the positive pin. If you didn't see that, you can take advantage of the virtual short and see that this right here is the same potential as V2, and so the current flowing here should be V2 over R3, and then once you have that current, you also have the voltage drop across R4, and you can find V out. And under this situation, when V1 is equal to 0, V out will be equal to 1 plus R4 over R3 times V2. Now, let's take a look when we reverse this. So in the other scenario, we will now put our signal in here, V1, and we will ground V2. So we're going to set V2 equal to 0. Now we'd like to know what the output is. The left-hand circuit, when we apply V1, is the non-inverting configuration of the op-amp. And so the potential at the output of that op-amp will be 1 plus R2 over R1 times V1. And if you didn't see that, you can solve the virtual short circuit as well, right? Just like we did in class. And so if that's the potential at the output of the first op-amp, the second op-amp is just the inverting configuration with this as the input potential. And so V out will be minus R4 over R3, that's the gain of the inverting configuration, times the potential at its input, which is 1 plus R2 over R1 times V1. And then by superposition, we can write that V out is equal to 1 plus R4 over R3 times V2 minus R4 over R3 times 1 plus R2 over R1 times V1. And this becomes a difference amplifier when the constant term in front of V2 is the same as the constant term in front of V1, because then we can write this expression as A sub D times V2 minus A sub D times V1. And that is the difference amplifier, with A sub D as the difference gain. So for that to be true, we need to set those two constant terms equal to each other. So we can write 1 plus R4 over R3 should be equal to R4 over R3 times 1 plus R2 over R1. And so if we write 1 plus R4 over R3 divided by R4 over R3 is equal to 1 plus R2 over R1. For the left-hand side of this expression, we can multiply top and bottom by R3 over R4. So we have R3 over R4 plus 1 divided by 1 is equal to 1 plus R2 over R1. And so the ones will cancel out, and R2 over R1 should be equal to R3 over R4. And so if we choose these ratios for our resistors, then the difference gain will be equal to either 1 plus R4 over R3, or you can use the right-hand expression as well. Right? And so now we have a difference amplifier with a gain of 1 plus R4 over R3. Now to find the common mode gain, what we're interested in is making V1 and V2 equal to each other, because now we will find the overall gain of the circuit for a common mode signal. And so we want to set, so we can write V out is equal to 1 plus R4 over R3 times V2 minus R4 over R3 times 1 plus R2 over R1 times, and then this is of course the common mode. So let me erase this. Instead of V2 and V1, we just have V common mode. Right? So we're applying the same potential at both inputs of this op-amp. And so the common mode gain is just V out over V common mode, and it is 1 plus R4 over R3 minus R4 over R3 times R2 over R1 times R4 over R3. And so those two cancel out, and it's just 1 plus R2 over R1 times R4 over R3. And if we're given resistor values, we need to first confirm that this is indeed true or very close to true. And if it is, if it's very close, you can just assume that the difference gain is this. Right? And then we can compute the common mode gain, and then the ratio of the difference gain to the common mode gain in dB is the common mode rejection ratio.